Recording started.
All right, hi Math 9 students. This is going to be a recording that's going to help us prepare for the final exam, which is going to be in a few days. And what I've done for this recording is I'm going over questions that some students had found challenging on the May test, which covered a lot of the concepts from across the year. And a lot of the concepts on the May test will also be on the final exam. And so I found that a number of students had a little bit of trouble with the circle geometry questions. So I'd like to start with going over those, and also went over and going over a number of questions that other students found a bit challenging as well. So let's get started then. First question here says to find angle X. And so we need to notice a few things about this question in order to find angle X. We notice that we have two types of angles here. This angle here is known as the central angle, and the reason why it is because it goes through the center of the circle, which is O. And we also notice that the other angle, angle X, as well as the central angle, both share the same arc. Okay, their 2 points of the angle are covered by the same arc. Now we have a rule that deals with that. And it says that if two angles in the circle share the same arc, and one angle is the central angle, then the other angle will be half as much. Okay, so half as much as 72 is 36 degrees. So angle X is going to be 36. So again, remember, if two angles in a circle share the same arc, and one of the angles is the central angle, the other angle is going to be half as much. Okay, so we're going to take that concept and just kind of tuck it away in our pocket for now, because we're going to need it for a later question, which is going to be this one. So let's look at this one. This one's going to be a bit of a puzzle, and we're going to work at it bit by bit. And so as we look at this question here, we notice that we have an isosceles triangle, that's ABC. Okay, that's an angle that has two sides equal. And so AB and BC are going to be equal. And it says that the center of the circle is O. Now we're told that angle OBC is 15 degrees. Now remember, when it says OBC, the letter that's in the middle, B, is the one that's 15 degrees. Okay, so this here is 15 degrees. Now what we're needing to find is BAC. So we're needing to find this angle. But first of all, we're going to deal with the small triangle, and that will help us to find this angle here. So far we know that this angle here is 15 degrees. And let's see where that gets us. Well, what we know in this small triangle, we know that this here is a radius because it goes from the center of the circle. But this side also has to be a radius because it also goes to the center of the circle. So that means that these two sides are equal. Well, what does it mean when we have two sides of a triangle equal? It means we have an isosceles triangle. And whenever the two sides of the triangle are equal, it means that these two angles also have to be equal. So this angle here, OCB, must also be 15 degrees. Okay, so where is that going to get us? Well, if this is 15 degrees, and we know that the three angles in any triangle equal 180, we know that this has to be 150. Because 180 minus the 115 degrees minus the other 15 degrees equals 150. So now we're going to redraw the diagram that we have right now, just focusing on this angle here, the central angle, and the other angle. And think to yourself at this point, if we have a circle that has a central angle and another angle, and they're both covered by the same arc, both subtended by the same arc, what rule do we use for that? Well, we use the same rule that we used in question 1, which was, if two angles in a circle share the same arc, and one angle is a central angle, which this one is, then the other angle, this one here, will be half as much. So what's half of 150? That's going to be 75. So BAC is 75. So you can see that we kind of used all different little bits and pieces, different pieces of knowledge to figure this out. We focused on the small triangle, and eventually we just kind of focused on that rule again that says that the central angle is going to be twice as much as the other angle if those two angles share the same arc in the circle. Okay, awesome. So now we're going to look at a question that is going to involve a slightly different law of circle geometry. And so let's look at the situation we have here. Well, we have a situation where the angle at vertex B, it says that it has a measure of x plus 30. Okay, so later on we can just label x plus 30 where we see B. And here it says that vertex C has a measure of 3x. So we can put 3x here. So that's what we're going to do later on. Then later on we need to find what x is. So we're going to have to do some math, some figuring out, and see what x is. But let's see what rule we're going to use here. Well, what do we know about angle B and angle C? We know that angle B and angle C are equal. And that is because if two angles in a circle are subtended by the same arc, that is, they open at the same arc, okay, then those two angles are equal. So this angle here, DBE, see it's covered by this arc, and this angle here, DCE, is also covered by this arc. They're both subtended by the same arc, the two angles. That means that angle B and angle C are equal. Now notice this is a different rule than the one we were looking at earlier because one of the two angles was a central angle. In this situation, we don't have a central angle. We just have two angles within a circle, and they're both subtended by the same arc, so they're both equal. So B equals C, and let's see where that's going to get us. Okay, well, since we're told that B is equal to x plus 30 and C is equal to 3x, if B equals C, then we can also say that x plus 30 equals 3x. So we write that down, x plus 30 equals 3x. Now if you look at what we have at this point, it's an equation, and it's one that's fairly easy for us to solve. And now we can find what x is, because that's what we're after. So when we move on to the next page, we use the rules for solving an equation. Remember, if we have an x on one side, a 3x on the other, we always want to get rid of the smaller x term first. So that's the x. So we subtract x from both sides. You can see that. And here when we have 3x minus x, that gives us 2x. The x is gone on this side. So we're left with 30 on this side, and we're left with 2x on this side. Now we have 2x equals 30. We know that we have x times 2, so we divide both sides by 2. And I'm not even showing that, but that's going to end up with x equals 15. Okay, great. So we found what x was, and that's what we were after. So again, remember that the rule that we used in this one is that if two angles in a circle are subtended by the same arc, that's this one here, these two angles, then those two angles are equal. Okay, awesome. So now we're moving away from circle geometry. We're looking at a question that deals with an inequality, and that's this one here. So first we have to solve the inequality, just like solving an equation pretty much. And then once we've solved it, then we can choose which one of these graphs tells us the same story as the inequality. Okay, so here's the inequality, and basically we solve it like an equation. So we kind of pretend it's an equation for the time being. Now, you'll notice we have x's on both sides. The first thing we do whenever we have x's on both sides, numbers on both sides, always get rid of the smaller x term first. So get rid of that 4x first. So we do 4x minus 4x, that's going to disappear. And then we're going to have 8x minus 4x on the right side, that gives us 4x. And you can notice that we're also left with minus 12 is greater than 4x plus 4. Okay, so that's what we have at this point. So what do we do next in the equation? Well, we want to end up with just x. We get rid of any numbers that are either added to or subtracted from the variable term. Remember, 4x is the variable term. So we're going to get rid of plus 4, so we need to subtract 4 from both sides. When we do that, the numbers go, and we're left with 4x on this side, and we have minus 12 minus 4. That gives us minus 16. Okay, we have minus 12, we go even more negative. We're at minus 16. So now we have 4x is less than minus 16. All right, our equation is even more simple. What do we need to do now? We have x times 4. The opposite of times 4 is divided by 4. So we divide both sides by 4. When we do that, we're left with x on the right-hand side. Minus 16 divided by 4 gives us minus 4. So we have x is less than minus 4. Okay? That's what this is telling us, right? When we look at this here, it's telling us x is less than minus 4. So what we're going to be looking for when we choose the correct graph at this point that tells the same story as x is less than minus 4, we're looking for a graph that shows all numbers less than 4. That's what it means. X is less than minus 4. I should have said minus 4 here. Okay? So we're looking for all numbers less than minus 4, but not including minus 4. Okay, so let's look for a graph that says all numbers less than minus 4. That is going to be graph D, this one here. Okay, you can see it's all numbers less than minus 4. Now you can see we have an open circle here because it's not less than or equal to minus 4. It's just less than minus 4. If it said less than or equal to, we would have a solid dot. But since it just says less than, we don't include the minus 4. And so this here tells us the picture of x is less than minus 4, or all numbers less than minus 4. Okay, awesome. So that's how we do that. Next question is number 5. Okay, a playground is rectangular in shape with dimensions shown in the diagram below. So we have 20 meters by 30 meters. It says, by how many meters must both dimensions of the playground be increased in order to double the area of the playground? Okay, so we're going to increase the dimensions. That means we're going to add a certain amount to both the length and the width. So we're either going to add 10 to both, 20 and 30, or we're going to add 20 to 20 and 30, something like that. But what we want to do is we want to find a playground that's going to have double the area of this original playground. So of course we're going to have to figure out what is the area of this original playground, and then what will the area of the doubled playground be. So let's do that. Okay, so here's just a picture of the playground we have now. The playground with increased dimensions, we don't know what it's going to be because we don't know how much we're increasing it by, but it's going to be a bigger one. But we do know that the area of the original playground was 20 by 30, and 20 by 30, 20 times 30 is 600 meters squared. So we know that's the area of the original playground. The question tells us that the new playground is going to have double the area, so it's going to be twice as much as 600, so that's going to be 1,200. So whatever the width and length are, they're going to give us an area of 1,200. So that gives us an idea of what's going on. We know that we're looking for a new playground with an area of 1,200 meters squared. So again, we're going to increase these dimensions either by 10, 20, 50, or 100. So what does that really look like? Well, this is kind of giving you an idea of what that's looking like. I crossed off the original dimensions of 20 and 30 because we're increasing them. So if we were increasing them by 10, instead of 20 and 30, we would have 30 and 40. Now 30 times 40 gives us 1,200, and that happens to be the number we're looking for. That's double 600. So far answer A looks pretty promising. How about answer B? If we increase them by 20, we will have 40 and 50, and 40 times 50 gives us 2,000. That's not 1,200. And similarly, if we increase them by 50, we're going to have 70 times 80, 5,600. Increase them by 100, 120 by 130. That's not 1,200 meters squared. So we can see that answer A, the first one we looked at, was correct. If we increase both of these by 10, we add 10 to 20 and 10 to 30, we'll have a new playground measuring 30 by 40, which is 1,200, which again is twice as much as the original playground of 600, which was 20 times 30. Okay, so we found the right one. Awesome. All right, so the next question deals with ratios and proportions. It says Pierre's class and Carissa's class have the same ratio of boys to girls. Now, I always find that it's good to underline key points. They have the same ratio of boys to girls. And it says Pierre's class has 18 boys, 12 girls. Carissa's class has 15 boys. How many girls are there in Carissa's? So it's good to write that down. Pierre's class, 18 boys, 12 girls. Carissa's class, 15 boys, X girls, because we don't know how many there are. But we do know that this is the same ratio. Okay, 18 to 12 is the same ratio as 15 to X. And so we wrote same ratio underneath. So once we have the information organized like this, that's great. We can put it in the form of a proportion, because we can put 18 over 15 on the one side. That's equal to 12 over X. So because we know that these two ratios are equal, we can set these two fractions equal to one another as a proportion. Now, you could have done it slightly differently if you wanted to. You could have made it 18 over 12 is equal to 15 over X. It doesn't really matter as long as you consistently relate the two numbers in the same way. So we set up the proportion like this. Remember, once you have a proportion, it's kind of screaming and asking you, cross-multiply me. So multiply the top of one fraction by the bottom of another. 18 times x gives you 18x. 12 times 15 gives you 180. So you have 18x equals 180. That's easy to solve. You divide both sides by 18. You get x equals 10. So Carissa's class has 10 girls. Not too bad, right? Okay, so let's look at another question that's also going to involve a proportion. This one involves similar triangles. So how do we know these two triangles are similar? Well, we're told that angle 1 equals angle 2, so we know that these two angles are similar, or the same, I should say. These 90 degrees are marked as 90 degrees, so they're also equal. And we know that if two triangles have two angles that are equal, the third angle rather, also has to be equal, because they all equal 180 degrees. Okay, so we do in fact have two similar triangles, and because we have two similar triangles, what that means is we can relate their sides to one another. And so we want to find the height of the tree, so we're going to call the height of the tree h. And we'll see how we can solve for h using the fact we have two similar triangles. Okay, so we mark this as h. So we set up a proportion where we have h over 475 on one side of the proportion. Now h, you can see that side is similar to this side here. So on the other side, we write it as 172, and we divide that by 190, because 190 is a similar side to the 475 was. So we've got our proportion. H over 475 equals 172 over 190. Again, we cross multiply. H times 190 is going to give us 190h on the left side. And then we multiply 475 by 172. That gives us 81,700. Now we have a simple equation. Again, divide both sides by 190, and you'll get h. And so we get h equals 430, and that's going to be centimeters. Okay, right on. So the next question we have here is going to involve using a number of different exponent rules. And so when you first look at this question, it looks a little more complicated, but you break it down and do it little by little, and it's not so bad. So you see you have all these exponents, and you have that expression here equal to 4096. We need to find out what n equals in the end. And for the time, we're going to kind of ignore the 4096. It's not really involved in the solution at this point. So let's just, first of all, review the different exponent rules that we're going to use to solve this one. First, we have the product rule, which says that multiplying like bases with exponents, when you do that, you add the exponents. So 2 to the 3 times 2 to the 5 both have 2 as the same base. And so we add the exponents, 3 and 5. So it becomes 2 to the 3 plus 5, or 2 to the 8. Okay, that's the product rule for multiplying powers with the same base. Then we have the quotient rule. So when we divide bases, or rather powers with the same base, so for instance 7 to the power of 5 divided, this should be a division symbol here, divided by 7 to the power of 2, we subtract the exponents. So it becomes 7 to the 5 minus 2, or 7 to the 3. Okay, so that's the quotient rule. Then there's the power of a power rule. So if you have a to the 5 raised to the exponent 2, we multiply the power or exponent inside the brackets times the exponent outside the brackets. So we multiply 5 times 2, which gives us 10. Again, the reason why this is called a power of a power rule, remember this whole thing is called a power, a to the 5, but it's part of another power because a to the 5 is kind of like a base raised to this exponent. Okay, so it's a power which is part of another power. And again, we multiply the exponents. So we're going to use all those 3 rules. All right, so when we focus on this here, what we want to do at this point is just focus on the top, the numerator or the top of the fraction, and we'll notice that we're going to use the power of the power rule because we have this power as part of another power. So again, that tells us multiply the exponent inside the bracket times the one outside. 5 times 2 gives us 10. Okay, now we're going to apply that to the actual part of the expression we have in the numerator. We have n to the 3. 3 is inside the bracket, 4 is outside. 3 times 4 is 12. Okay, so we're simplifying the top using the power of the power rule. N to the 3 times 4 is n to the 12. Okay, so we see this here, that now becomes n to the 12. So now our expression looks like this. We've simplified the top. Now we're going to simplify the bottom, or the numerator. And what rule are we going to use for that? Well, we're going to use this product rule, which tells us that when we multiply 2 powers having the same base, we add the exponents. Okay, so focusing on the bottom, which is n to the 6 times n to the 2, just focusing on that part here, we're going to add the exponents 6 plus 2, and we get n to the 8. So this bottom part, the numerator, is going to equal n to the 8. And so you can see, first we simplified the top and got n to the 12. Now we simplified the bottom and got n to the 8. And now we've got a more simplified expression. So now we're going to have to simplify n over 12 divided by n to the 8. Think about what rule you would use to simplify that. Well, we're going to use the quotient rule that tells us when we divide 2 powers having the same base, then we subtract the exponents. So it's 7 to the 5 minus 2 equals 7 to the 3. That's just the example. In this situation, we're dividing n to the 12 by n to the 8, and that becomes n to the 12 minus 8. We subtract the exponents. 12 minus 8 is 4, so this whole thing equals n to the 4. Okay, so we had n to the 12 over 8. That's simplified to n to the 4 equals 4096. Wow, now we've really simplified this whole thing, haven't we? We've got it down to n to the 4 equals 4096. And again, remember what we're after. We're trying to find n, the missing number. So, what does this really mean when we look at it? What does n to the 4 equals 4096? Well, n to the 4, n stands for a number, right? So n to the 4 means number times number times number times number, 4 times, equals 4096. So what you could do now on your calculator is plug in different numbers and multiply them 4 times, like 2 times 2 times 2 times 2. What does that equal? Well, that would equal 16. It wouldn't equal 4096. So next you might try 4 and see what that equals. Well, eventually you'd get to the point where you try 8 times 8 times 8 times 8. In other words, 8 to the 4 equals 4096. So n equals 8. All right, so again, this question had a lot to it. We used a lot of different exponent steps, power rules for simplifying things down to the point where we got it to look like this. But once we got it to look like this, it made a lot more sense as to what we were actually trying to find for n. The fact that n times n times n times n, or number times number times number times number, equals 4096. All right, the next one here says the simplified form of this expression is, okay, now when I look at this one here, I notice what kind of throws me off a bit is this part here. I have this minus in front of the brackets. I have to do something about that. What am I going to do about that? So that's kind of the tricky part. Well, a minus in front of a brackets really just means -1 times what's in the brackets. Okay, so it means -1 in front of the brackets, or -1 times what's in front of the brackets. So basically, whenever you have a -1 in front of a brackets, you just multiply that -1 times each term. So -1 times 4m is the same as -4m. -1 times -5n is +5n, because a minus times a minus gives you a plus. Okay, so we've got -4m plus 5n. That's what we got by simplifying this here. So we've already simplified this part, and now we're just going to simplify this part. I just wanted to, first of all, simplify the more complicated part, which was the right side. Now we'll simplify this. 6 times m gives us 6m. 6 times -2n gives us -12n. So now this part is 6m minus 12n. This part is -4m plus 5n. We've now expanded both the brackets, and now what we need to do at this point is to collect like terms. So we collect the m's together, and I put them in blue, 6m minus 4m. I collected the n's together, and you can see that 6m minus 4m is going to be 2m, right? 6 minus 4 is 2. Minus 12 plus 5 is going to be -7. So that's -7n. So now we found our final simplified answer. That's as simple as we can get. This is what we would write down as our answer. Okay, awesome. So the next question is asking us to look at this expression, and it says if it is simplified, okay, so first we have to simplify it, and that's going to involve like terms, just like we looked at before. Once we simplify it, then we're going to have to find the coefficient and constant. So let's review what those two things are. Well, if this is a math expression, we can see that a constant is just a number by itself. So -7 would be a constant, and so would 5. Whereas a coefficient is a number that goes in front of a variable. So I wrote this down. A number on its own is a constant. A coefficient is a number used to multiply a variable. 4x means 4 times x, so 4 is a coefficient. All right, so that's just a reminder of what a coefficient and a constant are. Now, remember, in this question, we have this math expression, and it says when it's simplified, we're going to find a coefficient and a constant. But this here, this expression here, is not simplified. We need to simplify it. So it looks like this, but first we need to collect like terms. So we put all the x's together, and we put all the numbers together. And that's why I put them in different colors. Now let's think about this. If we have -3x plus 1x, that's like -2x. -2x plus 3 is going to give us +3x. Here we have +5 minus 8, so for we have -3, and we go down another -7, should be -10. Looks like I did that wrong. Let me just review that again quickly. I have, I'm just going to look at the original numbers. So we have +5 minus 8 gives us -3, and then we have a -7, that's -10. Okay, so this here should be -10. All right, so since that's -10, we can see what we end up with. We end up with +3x minus 10. And again, I'm just going to change this to -10. Okay, so again, let's review. Again, the constant is the number by itself, right? Number like -7 or -5. So the -10 should be the constant. The coefficient should be 3. So we look for an answer that has a constant of, should be -10, coefficient of 3. And so I was wrong. It shouldn't be A. It should be B. Not sure what I was thinking there, but anyways, I definitely make mistakes. And the answer should be B. Okay. So, there we go. Let's look at the next one. The perimeter of a triangle, and this one is going to be the last one, by the way. Perimeter of a triangle is 24x minus 6. The lengths of two sides of the triangle are represented by the expressions 5x minus 7 and 2x plus 5. Which of the following expressions represents the length of the third side of the triangle? So again, the question tells us the perimeter of the triangle is 24x minus 6. Again, perimeter is the total length of all three sides. Okay? So, we're told the length of one side, we're told the length of the other side, we're looking for the third side, but we're told that these three sides added together are equal to 24x minus 6, because that's the perimeter, which is three sides added together. So what I've done is I've color-coded things to show the x's and the numbers. And so on the left side, when we're adding these expressions together, we can see we have 5x plus 2x, and that equals 7x. We have minus 7 plus 5, that equals minus 2. Okay, so we've simplified these two sides to equal this amount here. So that there plus missing side 3 equals the perimeter here. Now you can tell that side 3 is going to have to be 17x, because 7x plus 17x equal 24x. We predict that this is going to be 17. Likewise, we predict that minus 2 and then another minus 4 is going to give us minus 6, which we have on the right side. So that's why we're guessing that this is minus 4. Okay, so we have this as an answer. That's our missing side 3, and that's going to be answer D. And I guess I was wrong. There's one more question to do. We have to express this number in scientific notation, so we're expressing the product. Again, product is when you're multiplying two things together. Let's review how we do scientific notation. So for instance, if you write this number in scientific notation, there's two steps we do. First of all, we place the decimal to create a number between 1 and 10. So we put the decimal there to create the number 2.1, which is between 1 and 10. That's step 1. Step 2, count the number of digits to the right of the decimal. Okay, so since we have 1, 2, 3 digits to the right, the ones I have in bold, the power then is going to be 10 to the power of 3. So these are the two things we have. We have 2.1 and we have 10 to the power of 3. Step 3 is to multiply those two things together. And so it becomes 2.100 times 10 to the 3. Okay, so that's an example. Now we're going to apply that example to our question here. And so here's our question. We multiply these two numbers. On our calculator we get this number. That number now has to be expressed in scientific notation. Okay, so first of all we create a decimal. Place the decimal to create a number between 1 and 10. So we make it as 2.22. That's a number between 1 and 10. Now we count the number of digits to the right. Okay, so we have 2.22. Remember, we still have those zeros. So we have 5 digits to the right. So the power is 10 to the 5. Then we multiply these two things, the 2.22 times to the 10 to the 5, and that's our answer in scientific notation. Okay, awesome. So again, please practice these questions. There'll be similar ones on the final exam. Especially the circle geometry questions are ones that a number of students had incorrect on the May test. So, you know, after you've watched the recording, practice these questions on the PDF file. You can take notes if that helps you as well on anything that you think is important as you watch the recording. Hope your final exam goes really well on Wednesday. Thanks for watching, guys. God bless and have a great day. Bye for now.